Okay, so as promised, we're going to talk about a concept called the measures of spread. And a measure of spread is actually finding out how far 50% of your information is. All right. Now, let's go over central tendency. So measures of tendencies are values, the mean, median, mode, around which a set of data is clustered. So our biggest issue is analyzing the set of data. And it's useful to know how spread out the data is, right? Measures of spread show how the set of values are distributed. Now, the one that we're going to work on right now is going to be a thing called the box and whisker plot. And let's go over what this is. So I want you to consider these test scores. The test scores are 21 test scores, and they're all out of 100, right? Now, normally what we would do is we take all that information and organize it from least to small so that we could figure out the mean, median, and mode, right? Now, here's what we're going to do. We're going to take all this information and we're going to take a look at it and try to figure out the spread. So the spread that we're looking for is, hey, where am I going to get about 50% of the material that we have, right? The spread is saying, where can I find 50% of all of the numbers in my set? So here we go. In order to find that, we have to arrange the data from basically smallest to largest, so we can find this thing called a quartile. Now, think of a quarter. What does a quarter do? It takes $1 and breaks it into 4 parts of each 25 cents. We are essentially going to do something like that, but we're going to do it with the 3 quartiles, Q1, Q2, and Q3, so we can break up our list into 4 parts by using a thing called the median. All right, so here's the rule. Split your list into 2 halves by using the median. In this case, you got to remember that the new list that we have tells us that the following is true. N is equal to 21. Now, in order to split the list in 2, we're actually going to use the median. So just fill that in here. And then we're going to use a median of medians to split all of the data. So here we go. Let's go and split this list. So there's an N of 21. So the middle for the big side is going to be 21 divided by 2. And because it's odd, it's going to equal 11.5, which means the real middle is going to be 12. So now we're going to count 12 from the bottom, and we find out that our middle point is 69. And guess what that is? That's 69 in our percentage calculations. That 69 is actually a percent of all of the marks that we have now. That's 69%. And we call that Q2. That is the median. So make sure you write that in to your note, because I know that I wrote this. And so I never wrote the fact that this is the median. Now, here's the cool part. Remember that we use the median to kind of split this in 2. So exactly half of the information above it, and there's also half of the information below it. So think of this as 50 cents of my dollar is above it and 50 cents of my dollar is below it. Hey, so now what that allows us to do is we're going to take this block up top here, okay, and we're going to take this bottom block as well. And what we're going to do is we're going to do a median of medians. Now, here's the deal. When we had original 21 points in that list, now we do not count the 69, but we do count 71 through 90 and 48 through 68. Now, that is 2 even sets of 10. So our median is going to be here for the lower set, 59 and 59, which gives us an answer of, you guessed it, 59. So that is what we call Q1, right? And so now Q1 is the median of that block of blue there. So now we have 59% as our median for the lower half of our list. Now let's do that again for the upper half of our list. So for the upper half of our list, we've got 79 and 80 as our middle points because this is an even list, right? So now we know that this value is going to be 79.5 because we add 79 and 80 and then divide by 2 to get our value. So this is what we call Q3, and this is 79.5%. So that's interesting. Now, we also know that this is the smallest number, and this number here at the top is the biggest number, right? Number. So, how could we use all of that information in a graph? It's amazing that we can do this. So now let's go over how we go and do things like calculate the range and then calculate a thing called the interquartile range. Okay, here we go. So first of all, the range for us is always going to be the biggest number minus the smallest number. In this case, it's going to be 90 minus 48 for this set, right? And that means our range is 42%. We're actually saying that the range of numbers go, the actual distance from the smallest to the biggest number is 42%. That is what we're talking about. We're talking about the range of everything in the entire set. Now, when we talk about this thing called an interquartile range, we are looking for the difference between Q3 and Q1. So we want to see what the difference is for roughly 50% of all the information. We want to see how big the range is for 50% of the information that's which exists in here. All right, so we want to see how big a spread we have between here and here. So what we're going to do is we're literally going to take this concept of the interquartile range and we're going to subtract, we're going to find the difference between Q3 and Q1. So Q3 on our sheet is always the bigger number. So we're going to go Q3 minus Q1 for the interquartile range. And all we're going to do is punch in those numbers. So we're going to get 79.5 minus 59. So remember the two means, the two medians of each top and bottom half. That's what we're doing. So now you calculate and you end up with, I'm telling you, the spread between the smallest and the lowest of the middle 50%, the middle 50%, which is right here in our list, is a total of 20.5%. Now, all this stuff is kind of hard to read. I mean, looking at my list, this looks like a big, difficult thing to read, right? We got the smallest, we got the biggest, we got the quartile range 1, we got the median for the first half, the median for the last half, and the median for the entire set. it would be easier for us to see a picture of what that is, right? So imagine a genius comes up with this. They come up with the concept of a thing called a box and whisker plot. Now, a box and whisker plots will show us where Q1, Q2, and Q3 are on our list. Now, if you look here, these numbers go from the lowest numbers that we had on our list all the way up to our biggest number on our list. So notice we have 47.5 here, but you know what? This actually starts at 48. Oh yeah. So it starts at 48 here, right? So this is literally the first number on our box and whisker plot. So the key is when we draw this thing, we have to have a number line. And then below the number line, we show the first spot on our box and whisker plot by drawing a small line underneath our number line that we have right here. Now, remember, our number line goes from 48 all the way to about 90. And then we're going to go and draw the last spot on our list, on our box and whisker plot. And in this case, that number here is 90, isn't it? Yeah, it is 90. So I'm just going to take a moment. I'm going to write 90 in here. And this is the last element of our list. Now, here is the next thing. All right, now let's talk about the quartiles, right? So we had all of those quartiles that we calculated. Q1, we got Q1 up here that we calculated, which was the median of the lower list. And then we also calculated Q3, which was the top half of the list, right? And we also have the median of the entire list. Now you notice the median of the entire list is not included in that list. Sorry, those two lists, right? So now if we wanted to draw that, we literally have to draw a box to represent that blue highlighted 50% that I have for my information. So just remember, try to remember between Q1 and Q3, 50% of all the material is there. So it's very important for us to actually see where that comes from. So what I'm going to do is I'm actually going to take a moment and I'm actually going to mark off Q. Let's say there's the first, there's a second, there's Q2, and Q2 is 59. So let's write 59 here, right? And then here is where we write it. So we end up drawing a bigger line for our information, right? And we're going to call this line where it starts, that's actually our Q1. Okay. Now we're also going to do the same thing for our Q3. So our Q3 is, we have 79.5. So let's just put that in 79.5. And then we're just going to take a moment and we're going to draw a nice big line to kind of emphasize that between these two spots, between our Q1 and Q3, which I haven't labeled yet, Q3, we have 50% of all the information. And then we just have to put in our median for the entire set. So I'm just going to put that there. And our median for the entire set is 69. So at 69, here's what we do. we draw a heavy, I draw a big line which matches those other two, and I put a box around it. Now that box tells us that between here, between this spot and all the way to this spot, that's 50% of all the information from our list exists. Just like that highlighted blue section that we did. And that's how we draw a box and whisker plot. Now, the last thing to do to kind of emphasize the fact that all of this information is connected is we draw a line from the edge of the box to the two whiskers. And this is why it looks like a box and whisker plot. So we have a box for our Q1, our Q1, our Q2, which is right here, Q2, which is right in the center, Q2, which is right in the center, and Q3 at the end, right? And then the whiskers come off to go from the edge of the box to the first and the last point. And that's it. I apologize. I do get a little excited when there's a picture to be drawn. All right, so now let's move on to the last thing of the day. This measure of spread that we're going to be working with, right? The first ones that we did helped us visualize what was going on with the measure of spread, how spread out 50% of all our information is. This time we're going to actually have to do some calculations. So let's go over the concept of, put on your note this as your title, variance and standard deviation. All right, so here we go. So for our variance and standard deviation, here's what you need to know. So for variance, you have to do this and divide by this. So here's what it is. I'm going to write down the steps. So the steps are this. So first you list all your x's vertically. You call that x. 2, we have to calculate the mean. So next you're going to create a column that subtracts the x's from the means. And then the next stage that you have to do, if you look at what we did here, didn't we just square each of these results? So we have to square the x minus the means and put it in a new column. So we're just going to go and take the result of what we did in 3 and just square each of those terms in our new column. Okay? And then what you're going to do is you total it. And then finally, 5, you divide by n. And that is your variance. So remember, this is how we calculate the variance. So the variance is 1, list all the x's in a column. 2, calculate the mean somewhere. And then 3, take x from the mean. Boom. And then square your x from the mean in another column. And then you total it. Okay? This is important. If you don't total it properly, then your variance will fail. Once you've done that, you divide by n. And once you've got your variance, your basically standard deviation that we have is just the square root of the variance that you calculated from before. So let's go over some quick examples. All right, so let's do example 1's work for the day. So Ferd works part-time selling synthetic synthetic hairballs for cats, okay? So he recorded the number of hairballs he sold, and this is the number of hairballs that he sold, right, for the month in 12 months. So let's find the median, the first quartile, second, and interquartile range, and then we'll show a box plot. So the first thing we have to do is we have to order the list in order to come up with the median. So you'll notice this is our list. It's now ordered based on this list up here. So now what we have to do is we have to find the median. The first thing that you need to know is that there's 12 months, so n is even. So that means we're going to go and get the midpoint, which is going to be basically, 12 divided by 2 is 6. But because it's even, an even list, we have position 6 and 7 to average. And in order to identify that, you just count from the bottom, and you end up with position 6 being 25 and position 7 being 39. So so we're eventually going to have to average this. And you notice something? This thing here, that line that I have here represents the middle of those two numbers, right? So here's the rule. We average those two. So we go 25 plus 39 equals whatever number, and then divide by 2. And that means the median is equal to 25 plus 39 divided by 2, which ends up being 64 divided by 2, which ends up 32. So our median is 32. But here is the cool part. We can automatically say that the median for the entire list is Q2. So Q2 in this case is 32. And I'm just going to write 32 above the list in red because it's not actually in the list. And now we have to divide the top half of the list that doesn't include our Q2 and the bottom half of the list, which doesn't include Q2. Sorry. Yeah. All right. So now we have to find the median for the top and the median for the bottom. We're going to call this one, this lower half, Q1, and it's just the median. So let's do it. So the median in this case for this lower half is going to be between 13 and 17. Let's calculate. Well, that's just Q1. So in this lower half, we call it Q1, not the median. So we go 13 plus 17 divided by 2 equals 15. So Q1 is equal to 15. So similarly, we have a similar calculation for the top half, and I'll just show you the final answer. So we have 43 plus 44 divided by 2. You'll notice the top half median is called Q3, not the median. Okay? So now they've also asked you for the range, which is the biggest minus the smallest, which is 46 minus 6, which means our range is 40. So for the interquartile range, you have to be careful. It's always Q3 minus Q1. And so, yes, the interquartile range in this case is just going to be 28.5. So now the last thing that they've asked us to do is to do the box and whisker plot. Now the box and whisker plot is something that we've done before. So what we'll do immediately is we'll take a moment, and what we will do is we will zoom out a little bit so all the information is loaded and easy for us to see, right? So here's what we need to do. The first thing that you have to do is to create a number line. So just watch what we're doing. So I'm going to draw a number line. And thanks to the wonders of the internet, I didn't have to draw one. I just picked up one from the internet. So now we have to go and take our numbers and actually label them on this line. So remember, for the least version of it, we're going to go and put it as position 6. So this is 6, right? And we're going to make a teeny tiny little tick like this. Now we're going to do the same for the top half of our list, which is 46. So at 46, we're going to mark off where it is on our thing here. And we're going to call this 46. Okay. And like before, we just draw our little whisker for our whisker plot, right? So now we've got that. Let's go and put Q1, Q2, and Q3, those on our chart here. So now I've got 15. And I also have 43.5. So there's 43 and a half is right about there. 43.5. And so now all we have to do is we have to go and put our numbers we got to put it on our box. So remember that for the 15 and the 43.5 are the boxes. So here's what I'm going to do. I'm going to make a box that goes from 43 to 46. Okay. And now that I've got those two kind of organized, I can add the whiskers to my box. Okay. So now that I've done that, here's what we do. So for 25, for the last bit here, we have to put down the final thing, which is Q3. So Q2 is 32. So I'm going to mark off 32 on here. And then I'm just going to draw a line in the box where 32 is. And then we label this as the following. Here is the first number. Here is the last number. This one is Q1. This one is Q2. And this one here, this line here is Q3. And we are done our box and whisker plot. All right, so now we're going to calculate this thing called the standard deviation, the variance and standard deviation. This part here that we are doing is for calculating the variance. And in order to do that, you have to have your amount minus, you have to have your list like we have here. Then you calculate the amount minus the mean. Okay, so I guess the big issue is to figure out what the mean is. So imagine you do your calculations, you average out these numbers, and you end up with a mean of 75. So all that we have left to do for each of these numbers in the first column is to subtract them from the mean. Right. Okay, so imagine that we calculated the mean to be, remember it's the sum of what's in this column here, the amount divided by the total number. In this case, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we divide it by 12, and you do the calculations, and you end up with 75. So that's our mean. So now, once we've done that, we have to subtract. We make a second column where we take the amount minus the mean and subtract. So 61 minus 75, boom, get all these numbers here. And then what we have to do is we have to square each of these. So we have to square these. So this part, you square the results from the previous column. And now we get all of that. So you'll notice that -3 squared gives us 9, 64. -8 squared is 64. So if you ever have a negative sign in this column, you know you've done a wrong thing. Just drop the minus sign. And then here's what we do. We total up all those numbers in this column, and we get our answer here. So we end up with 1017. So the next stage of this is to calculate the variance. And the variance is equal to the number that I have here. We're going to put it right here. So we end up with 1017, and then we divide by the total number of points. In this case, we have 12 points. So we divide by 12, and we end up with the variance equal 84.75. So now the standard deviation is equal to the square root of the variance, which is equal to the square root of 84.75, which gives us a standard deviation of approximately 9.2. Okay, so that is basically it, right? So we got the number of 1017 from adding up those squares, right? Then we divided by 12, which came from the number of points in the list that we had here. And that's it. And so now take a look at this problem. All right. So this company needs bolts. Okay. For a heavy machinery company. The company must choose between two manufacturers, Clanco and Calitech. Which one is the better one? So let me explain to you how the standard deviation works with respect to this. When they say that the mean length is 72 and the standard deviation for Clanco is 2 millimeters, it means this. It means that I have the following. I have 72 in the middle, and this standard deviation thing means I can go up to 72 and down to 70. So it's like I can add that standard deviation. The same can be said for Qualitech, right? So if we take a look at this Qualitech company, the mean in this case is 72, right? And the standard deviation means it goes up by 0.1 to 72.1 or down to 71.9. So it's kind of like you're adding 0.1 and subtracting 0.1 from your answer. Now, if I look at this, it says, which manufacturer should I choose for that part? And I would tell you, I would choose this part because there is less of a change between its worst millimeter and its highest millimeter. In this case, it's 72.1 and lowest 71.9, but this one goes from 72 to, 72 plus 4 plus 2 is 74. So I'm not going to go with this guy that has such a huge change in millimeters. But this one, I can guarantee I'm going to have a really good experience. Now, here is the last question for you. Just write this down. It says, can a set of data be 0? If so, would this indicate what would this indicate about the interquartile range? Here is the example. So this is the answer. Here's the rule. If I have a list of just tens or the same number, the range is 0 because the last and the first difference is 0. The interquartile range is 0. And the variance is 0 because nothing changes. And then because there's no variance, there's also no standard deviation. Is 0. That's it. So your homework is going to be some of these questions here, right? Go for it. Do some of these problems and see what you get. Okay? Good luck. I won't ask you for all questions, but you will see what I want for your final submissions for this lesson set.